Hello everyone, welcome to the channel. For this tutorial, I'm going to go over programming on the Linux system. Now, programming on the Linux system is a very high demand skill to have because most of the companies test their software or run their software on the Linux system. And this is because the Linux system is cross-platform. It's also open source and free. It has powerful optimization capabilities. It also have extensive feature sets like GCC and G++ for C and C++ programs. You also have flexibility and customization, plus a lot more you can do on the Linux system. Linux offers a wide variety of programming languages to run on their system. We can run different programs, for example, Python, Bash, C, C++, and so forth. But for this tutorial, I'm going to focus on running C and C++ program on the Linux system. So there are two ways you can create a program in Linux. You can either use GCC or G++, which are suitable for smaller programs, or you can use Make and Makefile, which are suitable for larger programs. For this tutorial, I'm going to focus on GCC and G++, and I will create a different video for Make and Makefile. So GCC stands for GNU, or some people may say the GNU. So it stands for the GNU Compiler Collection, or the GNU Compiler Collection. So the GCC, or the GNU Compiler Collection, is a compiler system for various programming languages, and it is mainly used to compile C and C++ programs. So the GCC compiler is used to compile C programs, whereas the G++ is used for C++ programs. Now, you can run GCC to compile C++ programs. However, it will treat it as a C program. Okay. While GCC is capable of compiling C++ program as well, with the help of special flags, you should always use G++ instead of GCC for C++. The reason why: the G++ compiler links to standard C++ libraries by default. However, you can use GCC, but you have to link the standard C++ library yourself. Now, if you're on your system and you want to see if you have GCC or G++ on your system, all you have to do is use GCC version, and it will give you some information. Or you can also use GCC version, and it will tell you which version of GCC you have on your system. If you do already have GCC and G++ on your system, you can update the package by using sudo apt update, and it will ask you for your password. And once you enter your password, it will run the update for you. If you do not have the package installed on your system, then you can use the command sudo apt install, and you want to install build-essential. So build-essential contains various packages such as GCC, G++, and the Make utilities. So you would get all of the compiler in that specific package. So if I run this, it will install the package for me. So I already have the package on my system, so there is nothing to install. Now, if you're using Ubuntu or Debian, if you want to download the GCC and G++ compiler, the command to do that is sudo apt install GCC G++. If you are running Fedora, then the command to do that is sudo dnf install with one L GCC G++. If you are running Arch Linux, then the command to do that is sudo pacman -S GCC. I want to go inside of my program files folder because that's what I'm going to be using for this tutorial. Now, inside of my program file folder, if I do an ls, I have two programs in here. I have a C++ program and a C program in here. Now, before I run the program, if I go into VI and I say test.c, this is just a simple C program that say hello all, good day. For the C++ file, if I do vi stl_test.cpp, it's a simple C++ program that uses a map to print student name with their ID. I'm going to clear my screen. Before I run the program, I'm going to use the tree command. And the tree command will give me a structure of my files inside of my current working directory. So same as using the ls, but I prefer using the tree command. So right here, you'd see I have two files, as I showed before, my C++ file and my C file. So to run the C file, we're going to use GCC. So to do that, I'm going to say GCC -O. -O is used to specify the output file. So you have to create an output file and give that file a name. So the -O allows you to do that. So I'm going to give my file name test. So it's going to take the results from the test.c file and put it in my test file. Now you can name this file whatever you want to name that specific output file, but I prefer naming my file the same name as my program. So if my program is test1.c, then I will name my output file test1 without the C extension. And then you have to give the name of the program or the file that you are getting that output from. So the file that we want to use is test.c. So this is the input file and this is the output file. So the input file, it's always the program file that you're going to run. And the output file is what you created. So that's all you have to write for GCC compiler for now. So -O is called a flag, and this flag is just to give your output file a name or to create an output file. So if I go ahead and hit enter, everything works fine. Now, if I run the tree command again, it will show me tests inside of my current working directory. So I'm going to run the tree command again. And you see now in green, we have the test file. So in order to execute or run the test file, we're going to say /, just like how we run our bash file, we do it the same way for the C and C++ files as well. So we're going to say /, and the name of the output file. And the name of our output file is test. And we're going to hit enter. And we got back what we wanted. Hello all, good day. Right? So if I do cat on test.c, this is my printf statement. So this is going to print hello all, good day. And this is exactly what we got back. Now, you can also run this program by using one command. So instead of saying, we can say GCC -O, and this time let's change the output file name to test_c. And I'm just doing it for demonstration purposes, just to know that the code will still work. So test_c, and then we're going to give the name of the input file. If you want to compile the program and execute it at the same time, you use the &. And the && will allow you to use multiple commands. The && also makes sure that both operand is true. So we're going to say test_c. So the left operand, which is this part of the code, has to be true, has to run, has to compile properly with no errors. And if that happens, then we're going to run this. So I'm going to go ahead and hit enter. And you see it build the program for us, and it also execute it. So you can write all of this in one command just by using the double add. I'm going to clear my screen. Now, what happened if you did not give GCC an output file? You did not use -o. So let me run the tree command again. And you see that we have the test and test_c. Now, if I run GCC and just test.c by itself, it will still work. If I hit enter and I run the tree command again, if you look here, we have an a.out file. The a.out file, you would only get that file if you did not specify an output file for the compiler. If you did not use this exact command, you did not give the flag -o and an output file, it will create an output file for you, but it's going to call the file a.out. So if we come here and we do /a.out and we run it, we will get the same results. Now, there are some dangers of not specifying an output file, and all that is because if we're still working in the same directory, program files, and we run a different program, let's say we run the C++ program and we also forgot to specify an output file, this a.out will be rewritten. So you would lose all the contents of that file. So it's very important that you use an output file when you're running C codes or C++ codes on Linux. So I'm going to go ahead and clear my screen. Now that was GCC. Now G++ is for C++ program. I'm going to run the tree command again. You would see my C++ program here. Now I'm going to run this program using G++. So I'm going to say G++, and I'm going to give it -o and give an output file name. Now, before I do that, let's go back to not specifying an output file and let's see what happened. I'm going to go back and run the a.out file, and we have our C program. Now let's run the C++ program and not specifying an output file, and let's see what happened. So I'm going to say stl_test.cpp, and now if I do the tree command again, I still have only one a.out file. So let's see what's inside of that a.out file now. So I'm going to say a.out, and I get the result from the C++ program instead of the C program. So this was my C program, and now this is the C++ program. So you guys see the dangers of not specifying an output file. So let's try to run C++ program using GCC. So I'm going to say GCC stl_test.cpp. Now, if we look here, you can see that we got back some errors in our program. And it's because they're trying to allocate some of the libraries that we have inside of our C++ program, because the GCC compiler by default does not link to the C++ library. So you would have to do that manually. If you're running C programs, use GCC. If you're running C++ program, use G++. So same as GCC, we can say G++ -o, and we can give our file a name. So we can say stl test, and the name of the input file we want to get the data from is going to be stl_test.cpp. Now if I hit enter, everything is fine. If I go back and run the tree command again, you would see here I have my stl test file ready. So I can go here now and say stl test, and I will get the results from the C program. If you want to know exactly where this result is coming from, if I do cat stl test.cpp, this is this result here I want to be printed. Now if it looks a little bit different, we are using maps in C++, so maps by default will sort the result for you. Okay, so I'm going to go ahead and clear my screen. Now let's look at flags. In the previous command that we run, we use the -o flag. So the -o flag is to create an output file. Now there is another flag called wall. We can say G++ -wall, and wall give us a warning. The W stands for warning. So wall will print every warning so you can examine the code while it's running, right? So if we say -wall -o for our output file, we're going to say stl test. That's the name of our output file. And then we want it from stl_test.cpp. So when I run this program, wall will give me any type of warning that is in my program. So let's say, for example, I forgot to put a curly bracket. I forgot to use a variable in my program. So I have an unused variable in my program. Wall will print that warning for me. So I'm going to go ahead and hit enter. And there's a warning in my program for unused variable called ID. If I go ahead and say cat stl_test.cpp, this is my unused variable right here. There are several other flags you can use. For example, if you want extra warning, then you would do -w extra, and if you want to treat the warning as an error, then you use WERR. So you can go ahead and play around with these flags. Now you may also see stdc++ and the version, and that will specify the C++ standard use. So you can say the C++11, C++14. For example, you can say G++ std equals C++, and then you put the version number here, C++11. So that means you want to run your code on C++11, or you want to run your program on C++14, you want to run your program on C++17. You're just going to specify which version of C++ you want to use. Then you give the file stl_test.cpp. Now, if I go ahead and run this, and then I'm going to just run the a.out file. Now it run my program for me, but it run it in C++17. Now if you're running your program all the time and you know you use specific flags every time you run that program, the best way to do this is to create a file and put all of your flags that you frequently use in that file. So to do that, you can just create a file. So you can say cat and the name of the file. So the name of the file that we want to create, I'm going to call my file flags. Most programmers, they call their file flags. So I'm going to follow the convention and call my file flags as well. And in here, I'm just going to list all of the flags that I frequently use. So I frequently use wall. I'm also going to use -w error, and I'm also going to use -save-temps. -save-temps saves the immediate files in the same directory as the output file. Once you write all of your flags that you want to use, you're going to use -save-temps, and that will save that file in that same directory for you. So I'm going to go ahead and get out of here. So what I did, I pressed Control-C and get out of the program. Now, if I do cat flags, you would see all of my flags inside of that file. So if you want to run the STL test.cpp with our flags, so we can say G++, and we're going to run the STL underscore test, which is our C++ program. And if you want to use the file that you just created that has all of your warnings inside of it, you have to use the @ symbol. So we're going to say @ and the name of the file. So the name of our file in this situation is called flags. So we're going to say @flags. We're going to hit enter. This time, instead of a warning, it gives us an error, right? You see here, error, and it's using the W error flag, unused variable. So let's run the a.out file, and here is the results. If we go back and we say G++-wall, and we're going to give our file name, so STL underscore test.cpp, and we hit enter. You see here the difference, it gives us a warning, but because we are using the W error, right, it turns the warning into an error for us. So you see here, wall will give us warning and W error will give us error. So what we have learned here, W error will be prioritized over wall. So that's how you use GCC and G++ to compile C and C++ code on the Linux system. Now that's it for this video. Hope you guys learned something. If you did, please don't forget to like, subscribe, share, and I will see you in the next tutorial.